Let's summarize the entire chapter 14. It's all about the net present value for a new investment project that some company is considering. By definition, the net present value for any project equals negative initial investment in year 0 plus cash flow in year 1 discounted back by 1 year, so divided by 1 plus the discount rate, plus cash flow in year 2 discounted back by 2 years and divided by 1 plus the discount rate squared, and so on. So we would keep adding discounted future cash flows. First, we looked at what the correct discount rate for a new investment project should be, where it should really be coming from. And we used the weighted average cost of capital formula, which combines the cost of equity, the cost of preferred stock, and the cost of debt. So we were basically saying that whatever it costs the firm every year to pay back to the investors that bought its common stock shares, preferred stock shares, and bonds, that sort of average or weighted average cost is the minimum that the discount rate should equal. Otherwise, the project would not be generating enough money to pay make the expenses pay the expenses to the investors into the firm. We then talked about how the project's discount rate can be used. The project discount rate can equal the firm's WACC, but only when the new project is similar in its risk level to all other projects of the firm. The project discount rate cannot equal the firm's WACC when it has a different amount of risk. In that case, there are 3 solutions. Use divisional cost of capital, use pure play approach, use subjective approach. And we looked at the earlier slides what those 3 are all about. This was the first part of the chapter, the main part. We also talked about how raising money costs money. That's flotation costs. And that has to do not with the discount rate for a new project, but how much we truly need to invest into it. Because flotation costs are additional costs, we need to adjust the initial investment up. So whatever is required, we need to add something extra to it. That allows us to calculate the true initial investment, which is the initial investment that's needed for the project divided by 1 minus the weighted average flotation cost. The weighted average flotation cost combines the flotation cost for raising money from selling common stock shares, from raising money from selling preferred stock shares, and from raising money from selling bonds. So the 3 flotation costs for these 3 sources of financing may be different, and that's why we need to find their weighted average. So this is the summary of what chapter 14 was all about. And we first looked at 2 approaches for computing the cost of equity. One was using the CAPM formula. The other one was using the dividend growth model formula. How do you compute the cost of debt? Cost of debt is the same thing as the pre-tax cost of debt. That's basically solving for the yield to maturity, or IY, in a bond problem. The after-tax cost of debt is that number times 1 minus the tax rate, because interest payments on debt are tax deductible for businesses. And so effectively, the interest rate on loans is kind of overstated. How do you compute the capital structure rates required for the WACC? We need to look at market values of common stocks, preferred stocks, and bonds, rather than book values. So for example, for a bond, the book value is the $1,000 face value, but the market value of a bond is the price that you would pay to buy one bond. What happens if we use the firm's WACC for the discount rate for all projects. We may be incorrectly accepting something that should be rejected or incorrectly rejecting something that should be accepted. And that's because a firm's WACC can only be appropriate as the discount rate for a new investment project if the new investment project is similar in its risk level to the firm's existing projects. What are the three methods that can be used to compute the appropriate discount rate when the firm's WACC isn't appropriate? We may kind of borrow the rate of return from other companies that produce the same product as what our investment project would be all about. That's the pure play approach. Two, we may just add a couple of percent to our firm's WACC if the new project is riskier. That's the subjective approach, because we are adding a couple of percent subjectively. Why a couple of percent? Why not 3%? Why not only 1%? And the third method is called the divisional cost of capital, when each of firm's division may have its own appropriate weighted average cost of capital, and that should be the correct discount rate that division would need to use rather than the firm's overall weighted average cost of capital when the division is assigned to some new investment project. How should we factor in flotation costs to our net present value analysis? Flotation costs affect the initial cost of our investment. Flotation costs make the initial cost higher. When the initial cost is higher, the net present value becomes smaller. Thank you for watching.